Okay, so this week we're going to be starting our unit 4.4 on climate change. And so maybe this is something that you've heard a lot about. Maybe it's something you've got pretty strong feelings about. So we're going to be talking about this week. Um, if you remember back to last week, we were talking all about the cycling of carbon through the ecosystem. And if we start with atmospheric CO2, we know that carbon dioxide gets into our atmosphere a bunch of different ways, not the least of which is from respiration of many different kinds of organisms. So our producers do respiration, our animals use respiration, and also multiple classes of bacteria. And it doesn't matter what you are, a plant or an animal or these bacteria, all of them are going to use some form of respiration to break down energy. And when they do that, one of the waste products is CO2, is that carbon dioxide, which goes back into the air. So these are all naturally occurring processes that have been happening on this planet for billions of years. But what is new is the fossil fuels. So it's only in the last 200 years or so that we've figured out that you can burn these, get tremendous amount of energy, which is great. But when we burn them, that combustion releases huge amounts of CO2 into the air. And remember, this can be a kind of a problem for a lot of reasons, not the least of which is remember our ocean, right? So the ocean is the biggest sink for CO2. Most of that is going to dissolve into the ocean. And then remember that increased CO2 levels equal an increased pH. It makes it more, it's going to lower the pH. It makes it more acidic. And one of those intermediaries is that carbonic acid. It's going to decrease that pH, which is going to cause problems for our little mollusk friends, anyone who uses calcium carbonate to make those shells, because that decreased pH is going to dissolve those shells and make them more vulnerable to predators. And if you were really eagle-eyed during the, seasonal CO2 changes, you might have noticed that these lines are trending up. So, okay, on this side we have parts per million, which I'm assuming this is CO2. Yeah, because this is monthly mean CO2 as measured at this monitoring station somewhere in Hawaii. So parts per million of CO2, and then we have the years on the x-axis here. So yes, you have this, up and down of CO2 and that drop again is occurring during the summer months when photosynthesis is removing CO2 from the atmosphere. But in any case, every year it's going a little bit higher. You're seeing this upward trend. And it's not just causing a problem with acidity in our oceans. CO2 is also a greenhouse gas. It's helping to increase the temperature of the Earth. So here on this side of the graph, we have temperature in degrees. This is global average change. And then on this axis here, we have the year. So we're starting in 1880, and this is mapping out to about 2020. And then on this side here, we have carbon dioxide in parts per million. And so what we're seeing is in this red line here, the levels of carbon dioxide have been increasing basically since the industrial age when factories got really popular in the 1920s. People started getting cars more. And as the CO2 levels have been increasing since that time, so have the global temperatures. They're increasing kind of at a rapid rate now, and this has been going on for the past 200 years. So this is known as the greenhouse effect. And so I just want to emphasize here that the greenhouse effect is a naturally occurring phenomena. So these gases have existed in our atmosphere for a really long time for the most part. We've always had some methane, some CO2, and these gases will trap heat in our atmosphere. So they absorb it and they keep it there. And we're going to go into a minute and what those greenhouse gases are. So know that the greenhouse gases absorb the long wave radiation and re-emit it as heat energy. So have that in your noggin. So there are 4 greenhouse gases that I want you guys to know, and I've put them in order of importance, both in the graph and then in this order too. So The most important one to me is carbon dioxide. And that is because this is the only one that we are actively contributing to as far as levels. And it's emitted by fossil fuel combustion and respiration. So, respiration, as I said, has been around for like billions of years. It's only the fossil fuel combustion that has been recent and that's causing us issues. And again, remember, it is removed by photosynthesis from the plants, right? They take, or those producers, I should say, it's not just plants. So producers use photosynthesis to remove that CO2 to store energy from the sun in carbon molecules. And then the other thing that removes carbon dioxide from the air is the ocean. Again, because it's the biggest sink. That CO2 is just going to dissolve right into the ocean. So right behind that in terms of importance is water vapor. So, and you know that water vapor increases at least the feeling of temperature. You if you've ever gone outside and tried to run on a muggy day, you feel that heat. If you've ever been to, like, say, New Orleans where it's super swampy, you know it feels hotter there because it is, right? So water vapor gets into the air by just straight evaporation. So puddles sitting out, or out on the lake, sun shines on it, water vapor gets into the air. There's another process called transpiration in plants, which we'll cover more in a couple months. So that just, you can think of plants like exhaling water vapor, and water vapor is only removed from the atmosphere through precipitation. So like rain, snow, sleet, whatever. That's the only thing that's going to take water vapor out of the air. So even though water vapor itself adds more heat, we don't really care about it as far as a greenhouse gas is concerned because we're not out there adding water vapor to the air. So the next one is methane. So if that rings a bell from your methanogenic bacteria, it should, right? Because those methanogens release that methane, and you're going to find those again in the landfills or the waterlogged soil. So like if you've ever dug around in a pond and you see all these bubbles come up, that's probably methane. And methane can also be released into the air by fossil fuel extraction. And then we also have nitrous oxide, which is emitted by nitrifying bacteria, and you also find it in vehicle exhaust. So all four of these, carbon dioxide, water vapor, methane, and nitrous oxide, can all absorb heat in the atmosphere. But the most important one as far as we're concerned is carbon dioxide, because those levels are actually being affected by human activity, primarily because of this fossil fuel combustion, right? So the greenhouse effect is a naturally occurring phenomenon that is due to, the presence of these four greenhouse gases. But the enhanced greenhouse gas is different because it is not naturally occurring. The enhanced greenhouse effect is because of human activities, because we are burning more fossil fuels and putting more carbon dioxide into the air, we are increasing the global temperature. And that's, what's really driving this effect. So yes, greenhouse effect is natural, but this enhanced greenhouse effect that we've had for the last 200 years is definitely not. It's definitely because we are burning, so much fuels to like drive our cars and run the factories. That's causing these particular problems, right? So, okay. So long and short wave radiation. These are the two kinds of radiation that you're going to have to know. You're going to have to be able to tell me like who's who, give me an order here. So on your diagram, you have your happy little Earth. And like so many things in biology, everything kind of starts with the sun, right? So the sun is going to emit this shortwave radiation. And I could torture you with all of the things about nanometers, but I don't think you guys have to know that much. So know that the sun emits this shortwave radiation, a portion of which includes that UV radiation. So that's the stuff that like gives you skin cancer and sunburns. But luckily on Earth we have an atmosphere, and the atmosphere, specifically the ozone part of it, is going to absorb almost all of that UV. So 25% of the radiation is absorbed by the ozone layer, and most of that is that UV radiation that is harmful. But that still means that 75% of the radiation reaches our surface as heat, and it is absorbed by the Earth. So that energy, at least about a third of it, will get reflected or re-emitted as long wave radiation. So, okay, just to reiterate, short wave radiation comes in, Some of that gets absorbed by the ozone, so the UV is mostly taken out, and then 75% reaches the Earth, and then about a third of that is re-emitted as long-wave radiation. So short-wave radiation in, re-emitted long-wave radiation out. Okay? So 30% is pretty low number. And that is because something else is happening in the atmosphere. So like I just told you, there's greenhouse gases in that atmosphere. And what's happening is that about 70 to 85% of the energy is absorbed by those greenhouse gases. That heat gets trapped in our atmosphere because of them. And without them, we'd be a pretty cold Earth, right? So just to reiterate again, okay, remember, short wave radiation in, atmosphere removes most of the UV, but most of that radiation still makes it to the surface of Earth. Again, about a third is re-emitted as long-wave radiation. Some of that, most of it, is going to get trapped as heat by our greenhouse gases. So be able to draw that, be able to know it, and love it. All right. So we started out at the beginning talking about elevated levels of CO2 and that there is this increase in temperature because of it. So here we have a really sad looking polar bear that is standing on some melting ice. And so this has been causing some problems for our planet, and we'll be talking about that. So again, remember, because of those greenhouse gases, we're putting more of them, specifically that carbon dioxide, into the atmosphere, and that's causing the temperatures of the Earth overall to increase. And, you know, there's so much data about this out there, but just to reiterate, as CO2 levels rise, the temperatures are going to increase. So here we have levels of carbon dioxide, and I think they're using like ice core data to get this. So every time carbon dioxide spikes, we get a temperature increase, and this is a pretty drastic one here. And these are like from, you know, hundreds of thousands of years ago, so this is a pretty well-established pattern. CO2 goes up and temperature goes up. And so that's 400 years ago. You know, what's 400,000 years ago. It's not really related to what's going on now, because now the main driver of global warming is the combustion of fossil fuels. So we, you know, 200 years ago, we started with the factories, we started building cars, we started burning coal for our heat, which is putting tremendous amounts of CO2 into the air. Skip that. So the problem with all of that, and you feel this especially in the Arctic regions, is that melting ice is going to lead both to a loss of food and habitats for animals like the polar bears and the penguins. You know, the polar bears are adapted to match a snowy environment, and there's less snow there now, and there's been so many videos of them wandering around starving. It's really sad. The penguins rely on, you know, being the only ones that can survive in an Arctic environment. If all the snow is gone, that leaves their chicks, who are very vulnerable on land, open to predators. Especially so like this seabird here. So this albatross is trying to build a nest on a beach, and as you can see, it is surrounded by water. So those rising sea levels can cause habitat loss for the coastal animals. In some cases, it's eliminating islands altogether. There are many islands in the Pacific that have completely disappeared. The people that live on them have had to like move. And so like you see these, you know, sea turtles here. They normally nest on the beaches. If the beaches is completely flooded, the turtle has nowhere to put its eggs. And primarily the coastal cities are going to be affected like this. So like New York City, LA, everybody who's on a coast can expect that water to increase. So this is like an island that's been disappearing. So here's where they are in May 2018, and by that October it completely flooded over. And this is just the course of a month, right? So if we look at like, this is projected sea level rise for the next 100 years. I think this is the southern tip of Florida. Yeah. So within the next 100 years or so, expect most of the Florida Keys and a lot of Miami to be almost completely flooded out. So again, just to go back to that, CO2, when we have the increased CO2, the ocean is the largest carbon sink, and when the pH drops, it becomes more acidic. So this is what happens to the oysters. They use that calcium carbonate to make their shells, so they, become smaller, and they just don't survive because the pH is now acidic and it's dissolving their shells. These are important food sources for other animals. It's going to disrupt those, entire food chains. And so like the coral, that decreasing pH and the elevated temperature is going to cause like this mass bleaching. So I believe this is the Great Barrier Reef in Australia. This should be very colorful and beautiful, and it's just completely grayed out because this coral is dying. All right, so the other issue is extreme weather, right? So if we just turn on the news and what's happening in Australia, what happened in Puerto Rico just this past year, or the past couple of years, we've had these really destructive hurricanes. So global warming is driving these extreme weather events. It's causing an increase in drought and in hurricanes, which is not only really sad, but very destructive. So this is like was a picture of Australia during their most recent wildfires. This is a picture from space, and this is how much of the country was on fire. And I think they said about 1 billion animals died in this last event. And then this is a temperature map of the United States in January. And so I think here in Texas we're having a warmer than usual winter, but I'm looking at this in Boston, and I have never seen it be 70 in Boston in January. So this thing is real, and it's happening right now. So what can we do about this? We're not helpless in this. We can choose as a society to lower our CO2 emissions via industrial restrictions. We can, require factories, as we have done in the United States, to, burn cleaner fuels. We can choose to use alternative sources of energy, whether it's solar or wind power. We can ask for restrictions on our vehicles, as they have in the U.S. They're required to produce less CO2. But it's still not enough. So if we look at these are the biggest CO2 emissions, and the United States is not doing great for an industrialized country. We're higher even than India, which is really impressive since they have way more people. But the biggest offender right now is in China, and if you've ever seen news reports over there, you might see the smog that's in the city. So they don't really have the same environmental protections as we do here in the US, and we are still not doing a good job at controlling our CO2 emissions. So the US was supposed to sign the Paris Agreement, and then we kind of pieced out of the whole thing just last year. So that's not really a good way to go about this, but this is sort of where we are. So the last thing I want to talk to you about is the precautionary principle. So even though 97% of published papers back human activities as a major cause of global warming, there's still these people who want to argue that that's not what's causing it, kind of because I think they just don't want to hear it, because it means that we'll have to make some changes that they don't feel like. So the precautionary principle states hey, we don't care if you fully looked at the problem, even though I would argue that we completely have. But precautionary principle says that we should take preemptive action even if the problem is not fully researched. So even if it, isn't completely human driven, which again, just to reiterate, I really, really think it is, that we take preemptive action to do our part anyway. So just to review, greenhouse gas is a naturally occurring phenomena in which heat is absorbed and trapped in our atmosphere by greenhouse gases. So that part has been happening for, billions of years. And remember that our greenhouse gases include carbon dioxide, which is the most important one as far as I'm concerned, because it's being emitted by fossil fuel combustion, even though it comes from other sources like respiration, and that it is only removed by photosynthesis and dissolving in the ocean. Okay, and then after that we have water vapor, which does absorb more heat, but since we don't add water vapor to the air, we don't really care about it. But you also need to know that we have methane and nitrous oxide are greenhouse gases, so all four, in order of importance: carbon dioxide, water vapor, methane, and nitrous oxide. Okay. So know that the enhanced greenhouse effect is only referring to the part of this that is due to human activities, that is focusing on the burning of fossil fuels. So that is what's driving this. So know the whole short and long wave radiation. So know that the sun emits this short wave radiation, that 25% and the majority of the UV is absorbed by the ozone in the atmosphere. That's about 75% reaches the surface as heat and is absorbed by the earth, and that when it gets re-emitted, it is re-emitted as long wave radiation unless it is trapped by those greenhouse gases, which are carbon dioxide, water vapor, methane, and nitrous oxide. Okay, know that there is a correlation between CO2 levels and temperature. So when when carbon goes up, temperature goes up, and this has been, again, going on for hundreds of thousands of years. This association has existed. That the effects of global warming are primarily noticeable in those Arctic habitats, and it's causing the loss of habitat for those animals. We're losing complete islands here. We know that that increased CO2 levels on its own is going to increase the pH, which is going to start dissolving those mollusks and killing them right out. And that we have this rise in extreme weather events like the droughts or the hurricanes. And that the precautionary principle states that preemptive action should be taken even if the problem is not fully researched, that we should still get out and get ahead of this thing to try to do what we can to save the planet. All right, that is it for this one. Let me know if you have any questions tomorrow.